Hi, I'm Kristen Deem, and I teach physics at North Valley Christian Academy. I've been teaching for 35 years, but I just got the physics program 4 years ago. Slowly but surely, we have brought more and more technology into the classroom, and we were able to be more innovative with what we do. Some of their favorite labs is they did a mini launcher lab for projectile motion. They were able to shoot a marble in the air, and they had to predict where it was going to land and how long it was going to take, and they had to do all the math equations. The best part about it is when they weren't successful, they weren't allowed to quit. They had to go over and over until they were successful.
So like during the lab, we had to do a lot of trial and error. Even the smallest change, even an inch of change in degree on the device sent the ball way out of our target zone. So we had to really be meticulous and make sure that we had the rulers lined up correctly and do multiple trials until we got it right.
To start off the lab, we took a lot of initial measurements to find the initial velocity. And as we mentioned before, there's a degree of error, so we have to take that into account, take the initial height, and factor that into our equations. Try to accurately predict where the ball's going to land.
Recently we were learning about static friction, and so they were able to pull and see via a graph how long an object was under static friction, which means not moving, until it started moving.
So in the friction lab, we used the force sensor to pull a friction block, and we used SparkView to graph the force versus time.
Yeah, so we used multiple different services. We used our wooden table, we used the carpet, we used the hallway, and we used some concrete to achieve different levels of static and kinetic friction, so we could determine the relationship between the two.
We also did something that's called a modified Atwood, where they put a string on this cart and they put it over a pulley and they pulled it, and they were able to see how weights affected acceleration, and once again they were able to do graphs and calculate slopes of graphs and everything with the equipment.
So in this lab we have a Pasco smart cart that we use to collect our data, hooked to one of our iPads with SparkView. And this data is collected through a system of a string connected to a mass on one end, and then we add mass at the end of the string, so we just continually add more masses to it. And then for the second part, we keep the mass in the system the same by taking the masses in the smart cart and putting them on the pulley, and vice versa. That allows us to keep a consistent mass and allows us to analyze the effects of the mass distribution in a system.
Our program's really come full circle from when I started to now, and I just feel like we've developed a really strong program. My class is very close-knit. We only have 7 students, but they help each other, they work together, they set up the labs, they design them, and they become really proficient about using the equipment. And I feel like it's really helped us as a school. And you just see the excitement when they come in and they know they have a lab, and then they talk about it in the halls, and I hear other kids going, I want to take physics next year. And I think that's just a great impact on the school as more and more students get involved in the physics program, and we can continue to get more equipment so that they understand it well and can see how it's used in the world around them.